Okay. So good morning, everyone. So we'll continue with the work that we had done in the last class. So if you remember the last class, we have started with a chapter called the signal conditioning, right? Now in that signal conditioning, I think we have discussed, okay, basically what are called as the what do you mean by signal conditioning? Then the necessity of signal conditioning we have discussed, and processes of signal conditioning we have discussed, right? Then next we have started with what is called as the amplifiers, right? And then under the amplifiers we understood why we call those as the operational amplifiers, right? And then we understood about what are the different four features of operational amplifiers. Okay, that is input impedance is very high, output impedance is very low, and this acts as a differential amplifier. Okay, and the gain of the operational amplifier is very high. Okay, so these are the features what we have discussed in the last class. Okay, and to end with, if you remember, we wrote what is called as the 8-pin configuration of a operational amplifier. Okay, out of 8 pin, 5 pins are going to be active and the other 3 pins are not active. Okay, so these are the things what we have done in the last class. Okay, now continuing further, now we'll proceed for today's class, right? So today we'll try to understand the different types of what are called as the operational amplifier circuits. Okay, so now as I said, the operational amplifier, the word operational, okay, the word operational is going to be used to indicate that it is going to be used to do some different mathematical operations. Okay, right. So we'll try to understand which are those mathematical operations. Okay, now take the heading as types of op amps circuits. Okay, please, I want all of you to note down whatever I am going to do today completely. Okay, so these are all mathematical derivation. Okay, so take out your pen book. Okay, note down all the points whatever I am going to write. Okay, right. Now first one is called as inverting amplifier. First one is called as inverting amplifiers. Okay, right. So note down this diagram. This states about how we are going to use the operational amplifier for the purpose of the inverting, right? We noted down. Yes, sir. Yes, shall I proceed?
Yes, sir.
I will note it down. Okay, I may randomly ask the people to show what is that you have written. Okay, it's for your sake. Now you are all PG. Okay, I need to check what is that you are doing. Make sure that you are going to write whatever I am going to be write on this today. Okay, right. Now this is what is called as the inverting amplifier. Okay, now what is the inverting amplifier? Concept of inverting amplifier. Now if we assume, okay, so this is going to be the input that I am going to give. Okay, assume this is the input, which is nothing but your the V in. Okay, now what is the output? This is going to be your input signal, and what is the output signal which is expected from the inverting amplifier actually. So in case of inverting amplifier, the signal is going to be inverted. But what is the phase? Is it going to be in phase or out of phase? Is the question. Okay. So he says inverting. Okay, inverting means it is going to be increased. Amplification is going to occur, and also it is going to be out of phase like this. Okay, are you understanding? So this is going to be the output that what you are going to get. Okay, so this will be your the initial voltage. Okay, and that initial voltage is amplified to this much. Okay, and also it is out of phase is going to be the case, right? Okay. Now, this is the inverting amplifier. Now, inverting amplifier is what? Okay, so just make a point. This point as G. Okay, just write down this point as G. Okay, this one. Okay, right. This point as G. Okay, right. Now, basically, inverting amplifier is what? Inverting amplifier is the one whose output is out of phase by 180 degree with respect to input. This is very, very important. Okay. Inverting amplifier is one whose output is 180 degree, right? So this is the input. Out of the output is going to be out of phase by 180 degree with respect to input. Okay. Now, this is the circuit diagram which shows how the corrections are going to be made. Okay. Now, the input of the inverting amplifier, okay, has been connected to what? Connected to the negative terminal and positive terminal. Please observe, positive terminal has been grounded. Okay, the positive terminal was grounded. Okay, please understand. Okay, now the negative potential was given. Okay, now V in is the input voltage. V in is the input voltage, which is passes through, okay, the resistor R1. Okay, which is passes the resistor R1, and the input is connected to the ground. Okay, so this is called as G. Okay, now this is called as G. Now observe, V in is connected to the operational amplifier. Are you understanding? Understanding?
Yes, sir.
Input is connected to op amp, but the one of the minus and the positive terminal has been grounded. Okay, now that is, this is the inverting terminal, negative is the inverting terminal, plus is the non-inverting terminal. So non-inverting terminal has been grounded. Okay, right. Now we have R1. Now there is something called as R2. Okay, right. Now R2 is nothing but this is a feedback path. Okay, feedback path was taken from the output. The feedback path is provided from the output via resistors R2. Okay, R2 is nothing but the feedback resistor. Okay, R2 is nothing but the feedback resistor. Okay, this feedback resistor is given to the input. Okay, now this is the basic connection. Okay, now what is G is here, that is very important. What is G called as? G is called as summing junction. Okay, G is called as the summing junction or virtual ground. Okay, summing junction or virtual ground point. Okay, now this is the point wherein, okay, so here you are going to get, okay, now this is going to be your what? This is going to be your I out. Okay, right, reverse. So this is the V out. So the feedback resistor has been taken from the output through the resistor, what is called as R2, and it joins at this point called as G. Okay, right. Now, what is the current flows through G is the question. Okay, right. What is the current flows through G? Okay, right, is what is very, very important. Now, what was the first feature of operational amplifier? The first feature is, if you observe, input impedance. Okay, input impedance is very high or very low?
High.
High. Okay, so input impedance is very high. Okay, it means what? Virtually, it means what? Virtually, okay, no current. Virtually no current enters into the amplifier. Okay, virtually no current enters into the amplifiers. Okay, right. Now, what is the potential at G? Hence, potential at G is equal to what? Potential at G is equal to 0. Okay, right. At this point, okay, here no current will enter. Okay, right. Now R2 is what? R1 is what? R1 is the input resistance. R1 is the input resistance. R2 is the feedback resistance. R2 is the feedback resistance. Okay, R2 is the feedback resistance. Okay, right. Now I just repeat again. Okay, now we'll understand. Now what is inverting amplifier? Inverting amplifier is the one whose output is out of phase by 180 degrees with respect to input. Now the figure shows the connections made. Now the input has been connected through the resistors R1, okay, to the inverting terminal minus, and non-inverting terminal has been grounded. Non-inverting terminal has been grounded. Okay, and from the output, a feedback path was taken. Okay, remember, from the output, feedback path was taken, which passes through the resistors. What is called as R2. Okay, which passes through the resistor R2 and summed up at this point. Okay, this summation point is what is called as G. G is the summing junction. Okay, right. Now, as per the concept of the operational amplifier, the input impedance is very higher. Okay, so when I say input impedance high, virtually no current enters into the amplifier, hence potential at G is equal to 0. Okay, right. Now let us take R1 is the input impedance and R2 is the feedback resistance. Okay, right. Now let's just continue. Okay, right. Now, right. Now, what is as according to KCL. KCL is nothing but what? KCL is nothing but Kirchhoff's current law. Please note down. Okay. Note down, please. Please note down what is that I am writing now. According to Kirchhoff's current law, please note down. According to Kirchhoff's current law, okay, we have I in plus I out will be equal to 0. Okay, right. That is input plus output. Okay, current is equal to 0. Therefore, we'll take I in will be equal to minus I out. Okay, simple equations that we are going to write. Please note down. I in is equal to minus I out. Okay. Now we'll calculate the voltage across resistor. Okay. Now the note down the voltage across resistor R1. Okay, right. What is the voltage across resistor R1? Okay, so input is what? It is input minus output. Okay, that is input minus the summation of the point. Okay, is V in across resistor V in minus what is called as VG. Okay, right. So input across resistor R1 is V in minus VG. So what is the value of V in? VG. What is the value of VG? What is the voltage at ground point? Huh? Voltage at ground is 0. Okay, so that is VIN. Okay, voltage across resistor R1 is VIN. Okay, right. From Ohm's law, what is the equation of V? From what is V is equal to? From Ohm's law, what is V is equal to?
IR.
IR. Okay, V is equal to I into R. Okay. Now let us take for input resistance. Input is our input voltage. V is going to become V in. Okay, right? I is I in. Correct. R. What is the input resistance? R1 or R2?
R1.
R1. Good. Okay. So I will call this as equation number 1. Okay. So from Ohm's law, V in is equal to I in into R1. Okay. Right. Now similarly, we will write the voltage across resistor R2. Voltage across resistor R2. Okay. Is what? Okay. In place of V in, we will write V out minus Vg as it is. Okay. So again what? Vg will be equal to 0. So voltage across R2 will be equal to V out. Okay. Right. Now we'll write then again from Ohm's law. we'll write in the similar lines, okay, so that it's easy for understanding. From Ohm's law, V out will be equal to I out into what?
R2.
V out R2. Okay, V out is equal to I out into R2. Okay, right. Now we'll try to substitute I out in terms of I in. Okay, so what we know, but I in will be equal to what? I input. Input current will be equal to what? Input current will be equal to minus of I out. Okay, so therefore we'll calculate, we'll write down V out is equal to what now? I'll take I out. I out is equal to minus I into in, okay, into R2. Okay, right. We'll call this as equation number 1, 2. Okay, right. Now we'll divide 2 by 1. Okay, so what is that we are going to get? Tell me, V out by V in will be equal to minus I in R2 divided by I in R1. Okay, right. Now in gets cancelled. Therefore, V out by V in is equal to minus R2 by R1. Okay, right. So what exactly is this equation gives you? What is V out by V in means?
Gain.
Gain. Very good. Okay. So very important thing what we are doing is here is V out by V in. Okay. So V out by V in is equal to voltage gain. Okay. It is the voltage gain of the circuit. Okay. Right. So now this is the important thing. Therefore, what we are interested to know is what is the amount of voltage at the outlet. Okay, V out will be equal to, it is ratio of the feedback resistance to the input resistance into what is called as V in. Okay, if you specifically take V out will be equal to minus R2 by R1 into what is V in. Okay, right. Now, therefore, the voltage gain is the function of resistors R1 and R2, and it is always negative. Okay, what this negative sign indicates here? What is the why what is the significance of negative sign here? What negative sign indicates? Any guess? The negative sign indicates here that the output is inverted.
Out of phase.
Yeah, okay. So, in case of inverting amplifier, what is going to happen to the polarity? The polarity reverses. Okay. So, hence, the negative sign indicates that the output is inverted. That is nothing but how much degree out of phase? How much degree out of phase? 108. 180 degree out of phase with respect to input. Okay, so that is what is the indication of the negative sign. Okay, now this is what is the small derivation that you need to make it up when you are explaining about this inverting amplifier. Okay, right. So have you noted this definite equations?
Yes, sir.
Have you noted all of you? Shall I assume that all
Yes,
of you
sir.
have noted? Okay, right, good. Okay, right. Now just observe. Okay, I'll just go through fast. Okay, now G is called as a summing junction. Okay, or the virtual ground. And why we call it as virtual ground is because no current enters into that point. Okay, because why no current enters into that point? Because input impedance of the op amp is very high. Okay, therefore the potential at point G will be equal to 0. Potential at point G will be equal to 0. Okay, right. Now, according to the Kirchhoff law, current law, I in will be equal to minus I out. That means summation of current at the junction will be equal to 0. Okay, I in is equal to minus I out. So, we have calculated the voltage across resistors R1 and R2. Okay, now first one is voltage across resistor R1. That is V in minus VG. So Vg will be the ground potential, that is equal to 0. Therefore, the voltage across resistor R1 is equal to V in. So we know from Ohm's law the basic expression V in is equal to I in and R1. Okay. Now we have to calculate the ratio of the voltage. That is very important for me. Okay. So V in is equal to IN into R1. So similarly, the voltage across resistor R2 is V out minus VG. So VG will be again equal to 0. So R2 will be equal to V out. Okay. Now from Ohm's law, V out is equal to I out into R2. Now if I take the same thing in V in, I am having I in. In V out, I am having I out. Okay. Therefore, I thought of expressing this I out in terms of I in, so that I can able to cancel that and I will get only the voltage gain. Okay. So that was the important. Okay. So now accordingly, what we understood in the previous section is that I in was equal to minus I out. Therefore, we have resubstituted I out in terms of I in. So V out is equal to minus I in into R2. Okay. Now, so we have just taken this into our requirement. Okay. So we have called this as equation number 2. When I have divided 2 by 1, so I get rid of this I in. Okay. So I have left out only with what? So V out by V in minus R2 by R1. Okay. So V out by V in is nothing but output voltage by input voltage. That is nothing but the gain of the amplifier. Okay, if I give V in as the input, how much V out I am going to get. Okay, that is nothing but the ratio of voltage, the ratio of output to the input voltage is what is called as the gain of the circuit. Okay, therefore V out will be equal to minus R2 by R1 into V in. Okay, so this is the output voltage. Now here, what you need to observe here is the voltage gain is the ratio of the feedback resistor. Okay, voltage gain is the ratio of feedback resistor. Sorry, ratio of feedback resistor to the input resistors. Okay, right. And the negative sign indicates that the output is going to be 180-degree out of phase with respect to input. Okay, right. So this is about the first one called as the inverting amplifier. Okay, shall we go further? Okay, right. Now we'll correct. So after understanding this derivation, okay, now we'll go for one more derivation, which is the non-inverting amplifier. Okay, so make a note of this. Next one, non-inverting amplifier. Okay, so note down the circuit diagram first. Okay, note it down.
Yes, sir.
Okay. Right. Now, what is the output? Is it out of phase or in phase?
In phase.
Okay, so the output is going to be in phase, but the level of the voltage is going to be higher. Okay, now this is what is called as your non-inverting amplifier. Okay, just write down. Okay, non-inverting amplifier, note down, no. Just write down whatever I am going to say. Non-inverting amplifier, let's write the definition. Non-inverting amplifier is the one whose output is the one whose output is in phase. The output is in phase with the input. Output is in phase with the input. Okay, right. Now, in this case, output is in phase with the input. One second. Right. Output is in phase with the input. Here, write down inverting terminal. Note down this. Inverting terminal is grounded. Inverting terminal is grounded. Voltage V in is given to non-inverting terminal. Voltage Vn is given to non-inverting terminal, that is plus. Okay, right. V out is the output voltage. V out is output voltage, and R2 is the feedback resistance. R2 is feedback resistance. Okay, right. Now below that you write the voltage at node G is Vn. The voltage at node G is Vn. Since inverting and non-inverting, since inverting and non-inverting are at the same voltage. Okay, please understand this important. Okay, so the ground, now here also it is going to be V in, and here also it is Vn. Now why it is so is because as per the input impedance, the voltage cannot input, or the current cannot enters into the operational amplifier. Okay, and here also it is going to be I in current, and here also it's going to be I in current. Therefore through G, okay, through G, the current which is going to pass through is what is called as I in. Okay, right. So this is very, very important. Okay, so this point you just mark it as very, very important. Okay, right. Now apply Ohm's law to resistor R1 gives I in is equal to minus V in divided by R1. Okay, so minus V in for the fact that so V in has been given to this, and it will taken like this. Okay, so this moves. Okay, so minus V in divided by R1. Okay, similarly, if this is over.
Yes, sir.
Okay, so next one I am going.
Yes, sir.
Okay, fourth page, right? Similarly, applying, similarly, write down, similarly, apply Ohm's law to resistor R2 Okay, I out will be equal to, okay, I out will be equal to, so V out is the output voltage, V out is the output voltage minus V in is the input voltage divided by R2. Okay, right. Okay, now from this equation we'll take for V out. V out will be equal to what? V out will be equal to, we'll cross multiply I out into R2, correct? V out is equal to, so this I out into R2, this one will take it to the left. Okay, so minus V in, it's going to become plus V in. We'll call this as equation number 1. Okay, right. Now, applying Kirchhoff's current law at node G gives In plus I out will be equal to 0. Okay. So I in will be equal to minus I out. Okay. Right. So now from equation 1, means, sorry. Yeah. From, okay, we know that. Okay. This is what we know that. Okay. WKT, we know that. V in is equal to what? I in is equal to what? Minus V in by R1 from the previous discussion, correct now? Okay, so it was there on the previous page for me. So we know that In is equal to minus VIN by R1. Therefore, we'll write substitute for I1, substitute for I in. Okay, so what is I in is going to know? I in is equal to minus VIN divided by R1. That will be equal to minus I out. Okay, right. So R V in, negative goes out, I out into R1. Okay, so we call this as equation 1. We'll call this as equation 2. Okay, right. So we are interested, remember, whatever we are doing now here, we are interested to know V out by V in. For that only we are writing these equations. Okay, therefore we'll take now 1 by 2. Okay, V out by V in. V out by V in is equal to I out R2 plus V in divided by I out into R1. I out into R1. Okay, right. So what is voltage gain now? Okay, what is voltage gain? Voltage gain
R1, R2 plus Vn by R1.
Vn is equal to, okay, what is this now?
R2 plus Vn.
Okay, R2 plus Vn is what? Okay, Vn, okay, voltage. Okay, what is V in? We'll substitute V in the terms of like V in is equal to what? I out into V in is equal to I out into R1. Okay, that will substitute for V in also. I out into R1 divided by I out into R1. Now just observe. You got it? What is that I have substituted? I have substituted. Are you getting? V in I have substituted. Okay, from 2. Okay, from 2, VIN is equal to VI out into R1. Okay, so that I have substituted for V in. So it becomes I out into R1. Now you tell me V out by V in. What shall we take it out? What shall we take it out? What will not be there? Huh? I out, correct or what? I out, I'll take I out from everywhere. Okay, I out. Okay, R2 plus R1 divided by I out into R1. Okay, I out gets cancelled. Therefore, finally, V out by V in is equal to what? R2 by R1 plus what?
1.
plus 1.
1.
Right. So V out by V in is equal to R2 by R1 plus 1. Okay. Right. Now, what is V out by V in now? V out by V in is nothing but the gain. So now gain will be equal to ratio of resistance plus 1. That means what? It is inverted. The gain is greater than or equal to 1. Okay. Now it is, we are not having any negative sign here. Okay. So we are having positive. It means that the output is not going to be reversed. The output is going to be in phase with that of the input value. Okay, right. So generally these questions are going to be asked. Okay, so in the questions. Okay, that means the exam maybe for 6 or 8 marks. That is inverting amplifier and non-inverting amplifiers. Okay, right. Next we'll go further. Okay, we'll just at least write on the this one. What is that? The circuit. Write on the fifth one, fifth line, fifth page. Okay, summing amplifier. Summing amplifier. Write down clearly. It's also called as adder circuit. Summing amplifier, it's also called as adder circuit. Okay, right. Now, how the equation is going to be? Write down V1, 1, V1, V2, V3. Resistors are going to be R1, R2, R3. Okay. Current is going to be I1, I2, I3. Is it clear? Okay. This is taken into non-inverting terminal. Positive here, it is grounded. This is your I out. And there is a feedback resistance. This is called as RF. This point is G. This is I out. This is I. Note down this and tell me the summing amplifier is a form of. Okay, note down first. Note down and tell me, have you completed? Noted down?
Yes, sir.
Okay, right. Now, if you observe this circuit diagram, is it the form of inverting amplifier or is it a form of non-inverting amplifier?
Inverting.
Okay, so please observe carefully where it has been connected. Okay, now the input has been connected to the negative terminal. Okay, so this is the case of what is called as a inverting amplifier. Okay, right. What is the output that you are expecting here? Any idea? Okay, let me say like this. Okay, an simple example. Okay, V1, one input, V2, and another. Okay, so this is V1, V2, V3. What is the output expected? Just an example. Here I am having voltage level as A. Here I am having voltage level as B. Here I am having voltage level as C. Okay. What is the output expected? Or you can take V1, V2, V3 is the voltage level. Okay. So that's not required. Okay. V1, V2, V3 is the voltage level. Okay. What is the output expected? This is called a summing amplifier. Okay. What is that you are interested in now? Okay. You want to sum V1, V2, V3. Okay, is it only summing that you are doing, or what is that you are doing? Is it the output is only V1 plus V2 plus V3? Is the output is simply V1 plus V2 plus V3 or something else? What is this circuit? What is this circuit? Inverting amplifier or non-inverting amplifier?
Inverting.
Inverting. What is the concept of inverting amplifier? What is going to happen to the output?
180 degrees out.
180 degree out of phase. Is it going to amplify or is it going to be as it is?
Amplify.
Okay, so it's going to be amplification. That means what? Now you are going to have V1, V2, and V3. So the output is going to be what? The output is going to be 1. Okay, it's going to be V1 plus V2 plus V3 with the amplification. Okay, now we'll just understand this. Okay, now have we taken this circuit diagram first?
Yes, sir.
Okay, right. Okay, just note down. Figure shows the circuit for summing amplifier. Figure shows the circuit for summing amplifier. Summing amplifier is the one. Summing amplifier is the one whose output is inverted sum of input voltages. Whose output is inverted sum of input voltages. Okay. Whose output is inverted sum of input voltages. Okay. Right. Next line you write. The input signals V1, V2, and V3. Input signals V1, V2, V3 are fed through V1, V2, V3 are fed through R1, R2, and R3. The input signals V1, V2, and V3 are fed through R1, R2, and R3 respectively to the inverting terminal. Full stop. The other terminal is grounded. The other terminal is grounded. RF is the feedback resistor. RS is the feedback resistor. Okay. So from Kirchhoff's law, okay, what is I in plus I out will be equal to at this point 0. Okay. Therefore, I in will be equal to minus I out. Okay. Right. Okay. Now what is I in? So we have how many currents here to make I in? What is I in? At this point, what is happening with all this I1, I2, and I3 are all going to be merged here to get what is called as I in. Therefore, I in will be equal to I1 plus I2 plus I3. That will be equal to minus I out. Correct? Okay. Applying Ohm's law, we have I1 is equal to what? Okay. Tell me, I1 is equal to, in terms of voltage and resistance.
V1 by R1.
V1 by R1. Okay. I2 is equal to V2 by R2. I3 is equal to V3 by R3. Okay. Right. Now we'll substitute into this expression. Okay. Please observe. Okay. This expression. Okay. Right. What is I in now? That means this expression. Okay. What is I1? V1 by R1 plus V2 by R2 plus V3 by R3 will be equal to what is I out? Similarly, if you apply for this one, okay, I out also what is going to happen? Okay, so this is I out will be equal to, similarly, V3 means V out, correct or what? Divided by RF, okay. So minus V out by RF. Please observe this, okay, right? V1 by R1 plus V2 by R2 plus V3 by R3 is equal to minus V out by RF, okay. Now you take for V out now, okay. We'll take the equation for V out, page number 6. That is not equation number 6, that is page number 6. Next page is 6, okay, right. Now, what is write down for V out? Write down for V out now. Okay, what is V out? V out will be equal to minus RF, okay, V1 by R1 plus V2 by R2 plus V3 by R3. Yes or no? Yes or no?
Yes, sir.
Okay, right. Now, let's assume R1 is equal to R2 is equal to R3 is equal to R. Okay. Then V out will be equal to what? Minus RF V1 by R plus V2 by R plus V3 by R. Okay. Right. That is, we'll take R outside. V out is equal to minus RF by R into V1 plus V2 plus V3. Okay, right. Now, what is this actually means? This is the ratio of resistors, correct? This is nothing but RF by R. Okay, this is nothing but ratio of resistor. What is V1 plus V2 plus V3? This is the summation of input resistors. Okay, sorry, input voltages. Okay, hence write down, hence output voltage is the inverted sum of what? Inverted sum of what? Inverted sum of what? What are these?
Input voltage.
Input voltages. Okay, output voltage is the inverted sum of input voltages. Okay, hence it is called summing amplifier. Okay, hence it is called summing amplifiers, or also called as adder circuit. Means if you want to add the voltages, you can use what is called as the summing amplifier. Okay, therefore summing amplifier does what? Summing amplifier adds the addition of voltages. Okay, addition of input voltages. Okay, is it clear? Have you noted down?
Yes, sir.
Okay, if you noted down,
So,
yeah. Okay, so we'll just stop at this stage. Okay, now how many of you are there? 1, 2, 3, 4, 5. Only 5. Huh? Okay. Dhanush, Mithun, Arsha, Sandesh, Srinidhi. Okay, right. Okay. Right. We'll stop at this stage now. Okay. So again, we'll come back and meet at 10:50. Huh? Right. Thank you.
Thank you.
Okay. I'm leaving.